Select the reaction mechanism that best describes how hydroxide ion reacts with propanoic acid. So when we're drawing a reaction mechanism in organic chemistry, this means that we are drawing curved arrows. And when we draw our curved arrows, what those arrows indicate is the movement of electrons. And so these arrows always start from the electron donor. So this is where your arrow will originate, and it will end at the electron acceptor. And so if we're looking at an acid-base reaction, the electron donor is the base, and we know that hydroxide ion is a base. So I'm going to say base, and we're also going to call this the electron donor. And propanoic acid, from the name, we can see that this is an acid. So the acid is the electron acceptor. And so when we have hydroxide ion, the electron pairs that are being donated in this reaction are the electrons on the oxygen where we have that negative charge. And the electron acceptor is going to be the hydrogen that is attached to the oxygen. So the hydrogen attached to an electronegative atom will have a partially positive charge, and thus will be an electron acceptor. And so we will draw our curved arrow starting from the lone pair of electrons on the oxygen, forming a new bond to the hydrogen atom. And now hydrogen can only have one bond at a time. And so if a new bond is forming between this oxygen and this hydrogen, then the original hydrogen-oxygen bond needs to break. And so the oxygen that hydrogen was attached to had two lone pairs of electrons. And if we break the hydrogen-oxygen bond, we're going to take the two electrons from that covalent bond and give them to the oxygen. And so what this will form is it's going to take your acid and form the conjugate base. So the conjugate base, we have this oxygen. We had two lone pairs of electrons, and now it's gaining another pair of electrons from that covalent bond. So it now has three lone pairs of electrons, which means that oxygen has a negative charge. And the base has formed a new bond with a hydrogen. And that hydrogen is no longer attached to anything else. So this hydrogen will simply be attached to the hydroxide, forming the conjugate base of hydroxide, which is water. And so this reaction mechanism is consistent with what we see here in B.